Hello, Naka. Welcome to my ED350 Chemistry and Microteaching Assessment 1. This video is based on the determination of water crystallization. At the end of this video, students should be able to determine how to find the water of crystallization using the two methods. One is to find the water of crystallization using the theoretical value, and the other one is to find the percentage of water of crystallization using the experimental value. The first step into finding or calculating the theoretical value of water of crystallization, first step is to find the molar mass of the hydrated magnesium sulfate salt. Okay, so we have 1 magnesium plus 1 sulfur plus 11 oxygen and 14 hydrogen. That 11 oxygen comes from 4 plus 7 oxygens, right? Plus 14 hydrogen, that is 7 times 2, right? So if you're wondering where these numbers are coming from, that is from your periodic table, the molar masses of the different elements. So if you get to calculate it, the total will be 246 grams per mole. The second step, students, is to find the molar mass of water. Okay, as we all know that the moles of water is 7, okay, in water. Therefore, we need to find the molar mass of water, which is 14, okay, hydrogen plus 7 oxygen. Okay, so that 14 multiplied by 1 gram per mole, that is the molar mass of hydrogen, plus 7 multiplied by 16 grams per mole, which is the molar mass of oxygen. So your total comes to 126 grams per mole. That is your molar mass of water. Once you have found those two molar masses, then you can equip it into the equation, which is percentage of water of crystallization. Water of crystallization is equal to mass of hydrated salt, mass of water divided by mass of hydrated salt. Right? Multiplied by 100 over 1. So your mass of water is 126 grams per mole divided by your mass of hydrated salt, which is 246 grams per mole. And then you multiply it by 100 upon 1. So your answer comes to 51.22%. That is your percentage of water of crystallization. So there are two simple steps. The first one is for you to find the molar mass of the hydrated salt, right, using your periodic table where you get your molar masses. The second is to find the molar mass of water, okay, using the number of moles that is there in your hydrated salt. And then once you have found the two molar masses, you place it into your equation, which is the mass of water divided by the mass of hydrated salt multiplied by 100 upon 1, and then that will give you the value of your percentage of water of crystallization, theoretical value of percentage of water of crystallization. In order to calculate the experimental value, you need to first state what is given in the question, right? The mass of the hydrated magnesium sulfate, that is 2.46. The mass of anhydrous magnesium sulfate is 1.20 grams, and the mass of water of crystallization is 1.26. Hydrated magnesium sulfate means that it contains water, right? The salt contains water. And anhydrous magnesium sulfate means it does not contain water, right? So if you're wondering where I got the mass of water of crystallization, I subtracted 1.20 from 2.46. That is how I got the mass of mass of crystallization. So the first thing that you will do is that you will need to find your percentage of water of crystallization in the salt. That is where we use our equation, which is mass of water divided by mass of hydrated salt multiplied by 100 upon 1. Okay, so we have 1.26 grams, which is our mass of water of crystallization, okay, divided by our mass of hydrated salt, which is 2.46, and then multiplied by 100. So your percentage of water of crystallization comes to 51.2%. Okay, that is present in the hydrated magnesium sulfate. The second step is to compare the mole ratio, right? So that is where we use the mass upon molar mass. Okay, so we have our magnesium sulfate is to water, right? So we have our mass of magnesium sulfate, which is that anhydrous salt, which is 1.20 grams, divided by your molar mass, which is 120 grams per mole is to your mass of water, which is 1.26 grams, divided by your molar mass, which is 18 grams per mole, right? Which means your grams cancel each other out, leaving you with your moles, which is 0.01 mole is to 0.07 mole. And then you will have to divide your answers by the lowest mole, which is, in this case, it's 0.01 mole on both sides. So these two will cancel out, giving you 1, and this will give you 7. Therefore, the value of x is 7. And then you go on to your final step, which is to give the formula of your hydrated salt. So your hydrated salt will be MgSO4.7H2O. At the end of this video, I hope that you were able to learn how to find the water of crystallization using the two different methods. One is to find the theoretical value of water of crystallization, and two, to find the experimental value of water of crystallization. Thank you.